In this experiment, we're going to determine the stoichiometric relationship between sodium carbonate and sulfuric acid. The sodium carbonate is an anhydrous powder and it's free-flowing. Here I've got some already weighed out in these weigh dishes. The sulfuric acid, I've created a stock solution of 3 molarity concentration, 3.0 molar sulfuric acid, H2SO4, and I made that by dilution of the commercially available concentrated sulfuric acid. To begin the experiment, I'm going to set up an Erlenmeyer flask on which I've already recorded the mass on the side of the glassware. I'm going to add 20 milliliters of my 3 molar sulfuric acid solution to the Erlenmeyer. And finally, I've got 4 grams of our anhydrous sodium carbonate powder. Now I'm going to add this slowly at first, and then I'll speed up the addition rate such that I don't overflow the Erlenmeyer flask with bubbles, because this should react rather vigorously. And as we can see, it is reacting vigorously as the sulfuric acid reacts with the sodium carbonate powder. If I add it any faster, it will overflow with the bubbles. But there you go, nice vigorous reaction. That's what it looks like in real life. So here we've got 4 grams of sodium carbonate and 20 milliliters of sulfuric acid, and the last of it is finally reacting. I'm going to give it a good shake just to make sure I got it all, and I'll also grab a little pipette and get the sides just in case there was any solid powder left on the sides. Little bit of sodium carbonate still in there reacting and bubbling. Try get it all. There's just traces left. Few solid chunks in there that I haven't quite gotten reacted yet. As you can still see, there's a little bit reacting, and what that is due to is the fact that these sodium carbonate chunks weren't finely granulated enough. So I probably could have milled that or put it in a mortar and pestle and had it react a little faster. But if it reacted faster, maybe it would have overflowed the Erlenmeyer. There's just traces left, so now I'm going to add, and what we have is basically no bubbles going on here. It's pretty much all reacted. There is a little tiny bit there still going, but I'm going to go ahead and add 3 more grams for a total of 7 grams of sodium carbonate. And we can still see there must be plenty of sulfuric acid left because it's still vigorously bubbling. There. Now that's a total of 7 grams. And it's bubbling away. Now we're just going to wait for these bubbles to subside, get all that sodium carbonate reacted with the sulfuric acid. So in the sim, you will do this in a more detailed fashion. And you're going to be making a visual observations, i.e. the bubbles. And one observation I can make in the lab is that this is an exothermic reaction. It's nice and warm. It's probably about 30 degrees C. And now I can see that we got almost all of the sodium carbonate reacted. And no more bubbles. No more bubbles. So now I'm going to add another portion of sodium carbonate for a total of, we've got 4 plus 3 is 7 grams. I'm going to add 3 more grams for a total of 10 grams. And would you look at that? No bubbles. Furthermore, an observation I can make, but I don't know if you'll be able to see it in the HM sim, is that there is a solid precipitate at the bottom of this flask. And my assumption is that that is unreacted sodium carbonate. Sodium carbonate being soluble in water, but how soluble? That's the question. So just out of curiosity, I'm going to check the pH of this. I expect this to be basic now because sodium carbonate is a base. And if this is blue, then that'll confirm my suspicions. And it is. So what we have, no bubbles on that third addition of sodium carbonate. My sulfuric acid is neutralized. And I basically have a precipitate forming, or that formed, and it's sitting there happily at the bottom, but no bubbles from the third addition. And there you go. That's what the experiment is like, actually conducted in the lab. You will be doing it in a slightly more detailed fashion, again with the observations and the masses all along the way. Alright, this has been Mr. Davis. Thank you very much. We'll see you next time.